Hi, I'm Karthikeyan, Assistant Professor in Physics, Pratyusha Engineering College. Today we are going to see about an interesting topic, that is ultrasonic. Let's see what is that ultrasonic is. Let me split it into two. Ultrasonic. Ultra, we all know ultra high. Sonic. You might have heard this word in your practical subjects or in practical life. We might have heard this word sonic. Supersonic plane, for example. Sonic means sound. So, what's there in this ultrasonic? What is interesting about this? It's high sound. High in the sense it's above frequency of sound is about 20,000 Hertz. And you all know sound nothing but vibrations. Okay, so this is about the meaning of this ultrasonic. So high sound, the frequency is more than 20,000 Hertz. So let's talk about sound so that we can have a clear picture about this ultrasonic. So let's talk about sound. What is sound? We all know about this sound already. Let me reiterate what are the things you know already. So let me take sound. You all know it is vibration. Anything which vibrates is going to produce sound. For example, I'm talking, I'm producing sound. For example, I'm clapping, it's producing sound. What I'm doing actually here, I'm vibrating the particle which is present between my hands. I'm just making them to vibrate so that it's making that vibration and it reaches you as sound. So, vibrations. So, we all know the audible frequency range of humans, audible frequency range. Human audibility, we all know it is 20 Hertz to 20,000 Hertz. The frequency more than 20 Hertz and less than 20,000 Hertz. Let me divide. Below this 20 Hertz, we are calling it as infrasonic. Infra. There high, here less sound. In more than 20,000 Hertz, we are calling it as ultrasonic. So high sound. So we are interested about this now. So sound, we all know it is vibrations. Vibrations is nothing but waves. Let's talk about waves. Let me draw a graph between your time and amplitude factor. Let me draw a normal wave here. Wave, we all know wave. Thus, we call it amplitude of the wave. And we all know the wavelength. A single wave, what is the length? What is the length of this wave? We call it wavelength. Lambda. We give definition like the distance between two consecutive nodes or the distance between two consecutive antinodes. We call it wavelength. We call it amplitude. Then the important factor, that is your frequency. That's where we are interested here. Number of vibrations per second. Number of oscillations or number of vibrations per second. So number of vibrations. Let me iterate that in a simpler way. Let me draw two waves here. It's a wave, and another, I'm going to draw it a little bigger. So you can see the frequency here is more, that is, for 1 second, let me take these two of same time. In 1 second, we are having number of vibrations here, but here in 1 second I am having only one vibration. So it means that the frequency here is more. The frequency here is more. In 1 second, for example, if I have 3 vibrations. Likewise, in your ultrasonic, in 1 second, we are going to have 20,000 more vibrations, 20,000 and above vibrations. So, where it is useful, how it is useful to our normal life? Let's first talk about their properties and their working, then let's talk about their application part. So, first talk about their properties. What are the important properties they have? Your ultrasonic. It is same as your sound wave, nothing different here. You all know what is sound, the same as sound wave. It cannot travel in vacuum. Like your sound, it cannot travel in vacuum. And it can travel with the same speed as that of your sound. At normal temperature, room temperature, it can travel approximately 330 meters per second. That you all know. And the speed of the sound will vary. Depends on the density factor, and depending on the temperature, the speed of your sound is going to vary. That you all know. And it is an energetic wave. It can travel longer distance without much low in the energy. It can travel much longer distance. So these aspects we are going to use in practical application. So before going into practical application, let's talk about their how it can be generated. Generation of this ultrasonics. So we have n number of types we have. Today I'm going to talk about only two important methods. One is magnetostriction generator. Magnetostriction generator. And another important method is that piezoelectric generator. So what is a magnetostriction generator? It works with the principle of magnetostriction effect. Magnetostriction effect. For example, if a ferromagnetic material, when we apply magnetic field for the ferromagnetic material, it starts to vibrate. It starts to vibrate. That vibration will be equal to your ultrasonic frequency range, and it can able to generate this ultrasonic sound. That is about your magnetostriction generator. Next is your piezoelectric oscillator, or we call it piezoelectric generator. In this, we are going to use this inverse piezoelectric effect. You all know this piezoelectric effect. What is the piezoelectric effect? With a piezoelectric material, when we apply electric field to that, it generates pressure or vibration on the other two sides. The inverse of it. Here we are going to apply electric field. Because of the electric field, vibration will be generated on the other two sides. We call it inverse piezoelectric effect. Okay. Coming on to the application part, we have n number of applications based on this ultrasonic. We are using it in non-destructive testing. Without destructing any material, we can able to test the material. Any defect is there, any holes or any unwanted material is there, we can able to detect using this ultrasonics. By using ultrasonics, we can weld materials, we can join materials, we can put holes, we can clean materials. By using ultrasonics, we can have a very important application, that is sonography. You all know scanning of human body. The internal organs of human body can be scanned by using this ultrasonics. Based on the density variation, it scans the human fleshes, and internal organs can be viewed by using this ultrasonics. Another important aspect is that sonar. The distance can be measured by using your ultrasonics. So with this, let me close this topic, ultrasonics. Thank you for listening.